Okay, ladies and gentlemen, we're going to start slow and take very simple and step-by-step situations for different examples of motion on graphs. Okay, so the most simple example that we could possibly take is the example of a stationary object. Okay, so just like we have on the screen over here, let's suppose that I have x in meters over here versus time in seconds. Okay, and I want to show the motion of a stationary object. Okay, so there's +1 here, -1 here, -2. And in the example that I have here, I have the stationary object who is staying at -2 over time, over time, over time, never moving, never moving, never moving. So a stationary object is going to stay at the same position regardless of how time changes, right? So any time that you have a horizontal line in a position versus time graph, you have stationary motion, or you have a zero velocity, or you have an object that's simply not moving. Okay? All right. So that's the simplest example we have. Obviously, I can switch it up a little bit. I can have an object staying over here at 1 and never changing, never moving, never moving. That object is also stationary. Okay, so if you click to the next slide, and we look at the path of, let's say, an armadillo. Okay, so in this little guy's motion, I'm going to erase this here. I'm going to go over here, erase this. And the number line is going to change a little bit. Okay, and instead, down here we have 1, 2, 3, 4, 5, right? So at -5, like the motion of this armadillo begins, right? And they have something going on like this, okay? And so you have 1 second, 2 seconds, 3 seconds, and 4 seconds, okay? So here we have at 0 seconds, right? We have this armadillo here at -5, right? And one thing that you guys are going to learn is that the velocity of an object's motion is simply the slope at any given point on a velocity, on a position versus time graph, right? So if I have position and time, right, the slope of this guy at any given point is going to be the velocity. So the fact that he's got a slope means he's got a velocity or a speed, and he's actually moving. And so over time, he's moving in the positive x direction, right? Eventually, at x equals 3, or sorry, at time equals 3, he's at the origin, and the position is x equals 0, right? The origin is always x equals 0, okay? So at 3 seconds, he passes the origin, right? And then as time goes on, we get over here to 4 seconds, and we look over here, and we see that that's actually going to be 2 meters, okay? So the last example was a stationary object. Here's an object that's actually moving. In an object that's moving, what do you notice? You notice that the slope is changing, which means the speed or the velocity of the object is changing. And it's actually going to be at different positions over time, okay? Also intuitive, should make some sense, but I want to lay the foundations very clearly here. Okay, so in the next slide, we begin talking about average velocity, okay? And so I'm going to keep this graph up here for a second and just take note of this, that, at some position, let's take it at 1 second, right, as this example does, and then another position over here at 4 seconds, right? Okay? So in that time, this thing has gone from, -4 over here all the way up to +2, right? So there's like some genuine change in position, or in other words, distance, right? This guy's displacement has gone from -4 all the way up to 2, which is a 6 displacement, right? So the displacement of this guy is equal to 6. He's gone from -4 to 2. Okay, and so that's a lot like the rise, if you're doing rise versus run, right? Okay, and he's also moved from 1 second to 4 seconds. So there's also this run over here. So this is actually 3 seconds over here, right? So your average velocity, right, is just going to be, so if this is this, it's just going to be the slope between those 2 points, okay? So whenever you're trying to calculate average velocity, it's the change in total position divided by the total time that you've traveled, okay? So in this case, the average velocity of this armadillo, right, I'm going to put a little average sign here for average, is, I'm going to put displacement divided by time, right? This little armadillo fellow has gone 6 meters in 3 seconds. So the average velocity is simply 2 meters per second, okay? So now we've gone from this world of just using position, right, to actually finding what is the average speed of this armadillo over time, okay? And we've extracted that just from the graph, okay? So take a moment, look at that. When you feel comfortable, you can move on. And I